a Zener diode is used as a voltage regulator, okay, and like a fuse. What does the fuse do? When current passes through fuse, and if the current is higher, then the fuse will melt and the device is protected. Right? Fuse should always be connected in series. I hope you get what I'm saying. Suppose here is a bulb, okay, that you want to protect. So then you should connect the fuse here, so that if high current will flow, the fuse will melt and circuit will break. If circuit will break, current will stop. Right? Okay, so that's how fuse protect. Now, Zener diode is actually a similar thing, but instead of controlling the current, it actually controls the voltage. So it is supposed to be connected in parallel only. Right? Fuse should always be connected in series. Okay? Right? And Zener diode should be connected in parallel to whatever you want to protect. Right? Now, what's the basic idea of the working of Zener diode? Like, it's all based on those characteristics. Do you remember that a diode has forward and reverse bias characteristics like this? And I have a current here, voltage here. In reverse bias, up to some voltage, there is some small current in microampere, and then suddenly there will be breakdown and the current will increase. Now, Zener diode is even worse. When it comes to breakdown, this doesn't even go towards the right side, the left side. Instead of that, it's almost a vertical line, almost a vertical line. So what happens because of this? It's that, let's say this is breakdown voltage. Okay. Right? Over here there is breakdown. So after breakdown voltage, if you want to increase the voltage on the reverse bias side, the current has to be very, very high. You just think about what would happen if this graph was like this. So if voltage would increase, the current would not be that much, but arm size. So for going to, let's say, more voltage is here, can you imagine what I'm saying? That is basically when breakdown occurs in a Zener diode. After that, increasing voltage is very tough. Okay, for increasing voltage, the current has to be extremely, extremely high. So practically, we can say that Zener diode in reverse bias has potential difference of only 0 to 5 volts, because at 5 volt there is breakdown. Okay, it breaks down at 5 volt. What does that mean? It means when you connect to Zener diode in reverse bias, what can be its voltage? It can be anything between 0 to 5, but it can never be more than 5. Why? Because at 5 volt it will break down and then the current will increase tremendously, but voltage will not change. 5 to 5 will raise. Current will over there. Right? Okay, so basically it's not like it never increases beyond 5, but it will increase very little. Let's say for 5 volt the current is 1 microampere suppose. Then for 5.1 volt the current will become 1 milliamp. फरक तो जो आ 0.1 વોલ્ટ થોડું વધારવા માટે અહીંયા 1000 ટાઈમ્સ કરંટ છે, પછી હજી આગળ જાવ તો 5.2 કરવા માટે પાછું અહીંયાથી ઘણું બધું વધી જશે. મેક સેન્સ? Okay, so like that, to increase the voltage any further it needs lot of current. Okay, and that's not going to happen. I'll tell you why. So now how do we connect it and what really goes on? Let's say this is our bulb or any other thing. Okay, અહીંયા તમે કંઈ પણ મૂકો which you want to protect. Right? Okay, which you want to protect. And here you put a Zener diode like this. A Zener diode is symbol Z. Same as diode, isn't it? But instead of straight line, it's a Z. Got it? Z forward Zener. And then, like I said, you have to connect it in reverse bias. Only then it's going to do its magic. Only then it's going to do its magic. I mean internal resistance. So what's going to happen? As long as this battery provides voltage, let's say less than 5 volts, suppose 3 volt. At 3 volt everything is normal. At 3 volt we are in this region. There the zener diode basically doesn't flow current. Okay, here current is no. There will be no current over here. All the current will go through this. Fine. Bulb will glow very nice. But let's say some voltage fluctuation occurs. You understand what is the voltage fluctuation? Suddenly the voltage, let's say, increases, and instead of 3 volt, it becomes, let's say, 10 volt. Right? Instead of 3 volt, suppose it becomes 10 volt by a fluctuation. So now if this is 10 volt, right? If this is 10 volt, what's going to happen is here it will try to make current flow. Now when that happens, but the zener diode over here, what it does is it stops it. Why? Because the zener diode voltage in reverse bias can only go from 0 to 5. So out of halfway point of potential difference and 5 volt but not this. What I mean to say is VAB will not go beyond 5 volt. You understood? VAB will not go beyond 5 volt. Okay, why should this happen? Let's see. The answer lies in this way. Because when you try to increase the voltage beyond this breakdown, the current really increases very fast. So here current vodi jai to શું આમ current flow થશે. If this current will increase in zener diode, what's going to happen? Let's see. Suppose this current becomes let's say 3 amps, and this is internal resistance of this cell or whatever that is, and let's say that's only 1 ohm. How is that? Do you remember terminal voltage? Yes or no? So because of this high current flowing in it, આ current આવે ક્યાંથી? Ultimately battery માંથી આવે. Because of the high current flowing, the terminal voltage will actually become 10 minus 1 into 3. એટલે પાછું ઓછું થઈ જાય. Make sense? Like that, I've just given you an example with numbers. But did you understand the basic idea that this formula is telling you that if the current is very high in the circuit, then the terminal voltage will actually decrease. Who understood that? Nobody? આ ફોર્મ્યુલા જો આ ફોર્મ્યુલા કયા છે ને કયા ચેપ્ટર third v equal to third minus I. If the current is high, मैं ये ઊંધું લઈ if the current is high, then the terminal voltage will decrease. કેમ decrease થાય? ફોર્મ્યુલા દેખાય છે કે નહીં? S minus થયેલું ને, તો કરંટ જેટલો વધતો જાય એટલો ટર્મિનલ વોલ્ટેજ ઓછો થતો જાય. Is that clear or not clear? So that's what zener diode does. It allows very high current to flow. If current flowing is very high, the terminal voltage will automatically decrease. પડી સમજ? કેનો સમજ પડી? હજી ઘણા બધા નથી ખબર. Got it? I hope so. આમાં કઈ બીજું સમજાવવાનું છે નહીં. Right? So that's what the zener diode does. Now if that happens, like I said, if that happens, આનો voltage ઓછો થઈ જાય. Right? This is just an example with some numbers so you get a feel. કે આ 10 volt હોય તો અહીંયા 7 જ આવે. Like that, actually zener diode is a very good device. It sticks to 5. I repeat. It sticks to 5 volt. It changes don't. Right? So that's why this will get only 5 volt. If that gets only 5 volt, આ બે parallel માં છે. Yes or no? તો અહીંયા 5 volt આવે તો અહીંયા તો 5 volt. So this bulb will be safe. એનો વોલ્ટેજ ઇન્ક્રીઝ થાય. સપોઝ અહીંયા આ 10 વોલ્ટ નો બદલે સપોઝ અહીંયા 20 વોલ્ટ થઈ જાય તો એવી રીતે અહીંયા કરંટ ઇન્ક્રીઝ થઈ જશે. But however possible, it will keep VAB equal to 5 volt. And how will it do that? By increasing the current. If there is an increase in current, there is a decrease in the terminal voltage. It is a regulator. Understood the principle? Right? So let's solve some questions based on this. Right? The key thing to remember is this. Okay, so let's say we have got some voltage source like this. Even if you don't want to, if you just ignore this part also, then it's still going to be fine. Or to draw karo to that, because then we can say that from here something is there which will bring the current. Okay, and I have a circuit here. You want to protect this resistor. Okay, you want to protect this resistor. Or to same method, right? Now, if I tell you that, this Zener diode maintains 5 volt. If this Zener diode maintains 5 volt, okay, then how much current will flow in this resistor? That's what you have to find. Simple question. If this Zener diode maintains 5 volt, then how much current will flow in that resistor? Thank you. Diode and resistor are in parallel. So, आना कितना voltage? 5. So, आना कितना voltage? So, कितना current out है? Okay, that is going to be by R. It will current है. So, 5 divided by 10 raised to 3. So, answer is 5 million. As simple as that. Understood? Okay, so that's how you will do it. Right? Okay. You can, conversely, you can try and find out how much current passes through Zener diode also. Right? AY question is possible, then try this one. So, suppose here, let's say 5 ampere current is flowing, and here is a Zener diode. Okay, and over here you have connected something to protect, right? Let's say this thing has a resistance of, for example, 2 kilo, right? Okay, now the question is how much current flows through Zener diode. How much current flows through Zener diode? How will you answer? Use the standard Zener diode. Kind of given, and then you take the Zener diode reverse bias voltage as how much? 5. Take your call. What's the answer? 4.99? 95? 7? Okay, let's see. 4.9 current then. Okay, here. So this is 2 kilo ohm standard Zener diode 5 voltage, right? So there will be 5 voltage between these 2.5 volts. So that will give you the current here. Suppose I am IR, okay, or I1. I1. So I1 is going to be 5 divided by 2 into 10 raised to 3. Correct? Everyone got that? Correct that? Equal to how much? 2.5 milliampere or 2.5 into 10 raised to minus 3. Okay. Now 5 ampere here, 0.0025 ampere over here. Correct? So અહીંયા શું આવશે? Can you find it? कैसे कराए by using which law? અહીંયા 5 एम्पीयर, અહીંયા 0.0025, તો અહીંયા કેટલો આવશે? By using Kirchhoff's junction rule. Correct? याद आयो ने? So the answer will be what? 5 minus 0.0025. That is how much? 4.9975. Understood? Right? આ તો બહુ અઘરો ક્વેશ્ચન થઈ ગયો. આનાથી આવું તો નીટમાં બહુ ટફ પેપર હોય કે ટફ ક્વેશ્ચન જ ગણી શકાય. ઓકે? Yes, I'm not joking. આવું છે. Semiconductors માં મોસ્ટલી બધું easy હોય. So this is it. Here's the next question. Similar. પણ થોડું વાંચજો બરાબર ધ્યાનથી. Done. So what's the potential difference between point C and D? 9 volt. अच्छा यहाँ 9 volt. आप ये बताइए 70. So 8 volt. Who understood that? 8 volt. Very good. Bas thank you. Okay. Why is it 8 volt again? Total potential difference between these two is 70 volt. तो मतलब तो અહીંથી તમે આમ જાઓ તો 17 નીચે જવાનું, તો 9 અહીંયા નીચે જવાનું. ઓકે, વોલ્ટેજ ડ્રોપ હિયર ઇઝ 9, તો અહીંયા 8 જ હશે ને, તો 8 + 9 70. ક્લિયર? ધેટ્સ ઇટ. ઓકે, બસ હવે કઈ અગર ઝીરો ડાયોડના ક્વેશ્ચન વધુ નથી કરવાનું, આવું જ કરવાનું છે, રાઈટ? એઝ ઇઝી એઝ ધીસ. ઓકે, एक बात तो कह दो. Suppose you don't want, for example, like standard breakdown voltage 5 volt. Suppose you want to protect something that is 10 volt or higher. Then you will have to use multiple diodes. Do you understand what I'm saying? બે લગાડ દો તો આના 5 total થઈ ગયું 10. Got it? Right? Because in series the voltages are added. Very common. Right? So you can also do it like this. So whenever you want, you कदाच पूछी ले कि अभी एक सर्किट से we want to protect this, right? We don't want the voltage to increase beyond, let's say, 15 volt. So कितना diode लगाना? 3, like that. Okay. So एक last कर लें. It's similar to this question. The question is current in this resistor. Oh, डरावे जा. आ 12 volt to लेकर जो समझी क्या? The breakdown voltage of that zener. Actually, how the zener diode is made, depending on that, you can change the breakdown voltage, right? Standard 5. No like वो तो बच्चे जो आप do it. Okay. Give it a try. Done. Sorry, 6 milliampere. 12 volt, and a resistor. So 12 by 2 into 10 raised to 3. So 6 milliampere. Right? Okay, one more thing. Suppose in the same question if they say find the current here. So what is that? Don't guess, do it. Sorry? 1/4. The correct answer is 8 milliamps. Right? How do we get that? At 12 volt cycle. So how much does this give? 8. Clear or not clear? Because in series the voltages are going to be at. If you do not understand that, no problem. Use Liptoff law. Okay, then I'll loop after. So starting from here, minus I into 10 raised to 3. Barabar? Now when you go from here to here, there is a voltage drop of 12 volt and a minus 12. I hope you remember that when you go from higher to lower, you write negative. Correct? And then now you come back and you go through this. So plus 20 equal to 0. Understood? But I solve for it. So A is equal to I into 10 raised to 3. Again answer. Understood? This is official method. बाकी में theoretically साथ होते हैं. 12 आना. And this is giving 20. 12 is here. So remaining is 8 for this resistance. Okay, 8 volt. So 8 volt is 8 milliamp. अच्छा, अब zener diode में current find करो. Can you find current in zener diode? Current in zener diode 2 milliamp. Is that clear or not clear? Save the 2. 8 amp. 6 amp. So बाकी नो याद है ना? Yes or no? Okay. So that's what we have. Right? Fine. હવે ખરેખર કઈ જ કરાવવાની જરૂર નથી zener diode. Okay. Now, this chapter we don't have, I mean, there is photodiode, there is LED, but what I do is, I'll give you notes first of all, right? You go through the notes once, okay, and then we will discuss it, right? So, we will be able to do it fast, and normally, I do not have to tell you all the mundane details like this structure is made like this and this is made like that and all that. Okay, I have the note ready with me, made from the textbook of course, right? But trust me, it's much better than reading the textbook. It's short, you can also use it for board exam if you want, right? I don't have everybody's phone number to be frank, so I'll try to send it to as many people as possible, whose numbers I have. If you don't get it by tonight, you can send me a message, I'll send it to you. Alright? Okay, because I don't have everyone's number. Only those people's number who might have contacted me earlier, I have them. That's it. Right? So if you don't get it, don't think like sir didn't send it to me. It's not like that. Okay, it's just that I might have forgotten, or it's possible that I might not have saved your number or whatever. Right? Okay, or you can always get it from your friends. I don't mind. You can share it with others, no problem. Okay, there's no such secret inside. Right? Yeah, the note also includes transistors and all that. Right? Okay, now whether to study about transistor or not, that we will see later. Okay, let the notification of NEET be out. Let's see what they're going to tell you about the syllabus. Let's see whether you get options or not. Okay, why am I saying that? Because First of all, you don't have transistor in body. Second thing is transistor is a fairly long topic, not tough, long. Okay. So the question is it worth spending 4 or 5 lectures explaining everything about transistor? Right? Inside a transistor content will have semiconductor chapter 50% system. Right? So we'll see. Right? Later. નોટ્સ તો તમને આપી દો પછી તમે રાખજો વાંચો એ તો વાંચજો અને એમાં તો એવું છે કે બુકમાં જે 3 લાઈનમાં તમને એવું હોય ને તમે વાંચો તો ખબર જ નહીં પડે તો એ 3 લાઈનનું મેં એક પેજ બનાવ્યું છે એવું ઘણી વાર થાય રાઈટ નોટ ઇન અધર નોટ્સ ઓનલી ઇન ટ્રાન્ઝિસ્ટર કારણ કે ટ્રાન્ઝિસ્ટરનું બુકમાં આવું ઠેકાણા વગર વાંચ્યું કંઈ સમજ જ નહીં પડે રાઈટ ઓકે નાઉ so we'll have to do something else today. Right? What shall we do? Let's solve questions related to chapter 4. That is moving charges and magnetic field and all. Okay? આવડશે ને કે નહીં આવડે થિયરી હું તમને થોડી થોડી યાદ કરાવી ઓકે ડોન્ટ વરી બટ કે બીજી કઈ તમારી રિક્વેસ્ટ છે અબાઉટ એની પર્ટિક્યુલર ચેપ્ટર તો ઈ કરીએ પ્રેક્ટિસ જ કોઈ સિલેબસ તો કઈ હું રિપીટ કરવાનો નથી ભણાવવાનો નથી બીજી વાત ઓનલી ક્વેશ્ચન બોલો એની particular request about any other chapter later આપણે force કરીએ anyone okay sure one minute. I'll keep it in short. Shape drop arrow current carrying ring we had a topic magnetic field due to current carrying ring okay pehla to magnetic field at center of current carrying ring ની formula છે mu0 પછી ni પછી upon 2r okay and at some point on axis any formula છે તો DC માટે શું formula યુઝ કરશો mu0 ni square mu0 ni r square upon 2 into x square plus r square raised to 3/2 or r square plus r square if we call this x right યાદ આવી ગયું you can write r no problem તમને એવી જ મેં કેવું પડે ઓકે તો આ બેનો યુઝ કરવાનો to find out what it is. The first thing that you should do is divide this into mu0 and I all are cancelled and then remains what's that આવી ગયો આન્સર? बार नोला भी જોઈએ 1 મિનિટ ધેટ્સ ઇટ ના તો મેં તમને ડાયાગ્રામ ડ્રો કરી દીધો ક્વેશ્ચન માં ડાયાગ્રામ નથી યુ હેવ 3 લાઇન્સ ટુ રીડ ઓકે એટલે એનો ટાઈમ કોણ થોડી સ્પીડ વધારવી પડશે બધાને ડન એનાથી વર્તી આવો 250 માઇક્રો ટેસ્ટ હા ઓકે ધેર ઇઝ સચ એન ઓપ્શન 250 ઓકે ચલો એક વાર નાખો બરાબર ને like I said, divide there. So if you divide BC by BP is equal to 1 upon 2r, કારણ કે mu0 એને cancel, પછી ઓલું divide કરવાનું એટલે એનો reciprocal 2 into r squared plus r squared by 2 divided by r squared. Right? Let's put all values. 1 by 2. What is r? 3. જો આમાં કેવું છે ખબર છે? If you don't put it in meter, it's fine. समझ पड़े क्यों? Because everywhere, look at the right side. Everywhere it's all distances, radius, distance, and they are all in which unit? Centimeter. Understood? So if you are going to put everything on the right side in centimeter, it's going to be fine. કારણ કે બધું cancel, unit બધા cancel છે. So 2, 3, અહીંયા શું આવશે? 9. અહીંયા 3 square, 4 square plus 3 square, that is 5 square. So 5 square નું cube root કરી cube કરીને કરો એટલે 5 cube. Okay, this is clear. 5 cube, right? Then एक आठ 2 रहेगा तो you will do yes. Okay, done. So 2 cancel. So this final answer is going to be 125 divided by 27. અહીંયા શું છે? BC upon what's BP? 54. તો આને કટ કરવાનો. અહીંયા 2 આવી જશે. આન્સર આવી ગયો ને 250 micro test. Clear? Okay, here's the next question. Right, this question is about, first of all, some current flowing like this in semicircular rings or loops. Okay, what do we have to find? First question, what do we have to find? Magnetic moment. What is formula of magnetic moment? NIA. So turn to a person. Right now, which area should you take? Our shape I was a area level person. Can you describe that area in words? Can you describe that area in words? Which area should we be taking here? રેક્ટેન્ગ્યુલર લૂપ હોય તો આપણે કયો એરિયા લઈએ? આવું હોય તો કયો એરિયા લઈએ? ઇનસાઇડ. તો આમાં કયો લેવા? Hint. You have to take the area between the wires. Yes or no? Area that is enclosed by it. Correct? તો આમાં કયો એરિયા લેવો પડશે? Yes, the larger semicircle minus smaller semicircle. Find your answer. ચલો જલ્દી. Done. મજાક ન કરો એટલે થઈ જાય ન થઈ જાય. What is area of larger semicircle? Area of larger semicircle pi r squared by 2. Smaller semicircle pi r1 squared by 2. બેને સબટ્રેક્ટ કરો into what? Into current. આવી ગયો ને તો કેટલી વાર લાગે? I was right in expecting the answer immediately. Am I not right? So the first answer is M equal to I into pi by 2 common r2 square minus r1 square. Clear? એ આવા ક્વેશ્ચન હોય આવા છોડીને ન આવવાના હોય એમ ઠાક 10 સેકન્ડમાં પૂરું કરીને મૂકી દેવાના હોય. બરાબર? Next, this one. Solve this. Now you have to find the magnetic field at the center. simple philosophy that we have from 11th standard. Whenever you see some complicated objects, what to do? Divide them in some simple. So તમને semicircle નું આવડે ને find કરતા, because semicircle is half a ring, isn't it? તો આવડે કે નહીં? half a ring એટલે half turn, correct? half ring એટલે half turn થાય ને, એનો સમજ પડી? અડધી. So 1 and you have 2, પછી આનું શું અને આનું શું? It will be 0. એક concept આવ્યો હતો જો આ બધું ટેક્સ્ટબુક માં તેમાં કંઈ જ આપણે મિસાઈ નથી કર્યું અને કંઈ બહાર નહીં નથી. If you remember, you have a straight wire and you take a point which is in line of that wire, the magnetic field is 0 due to Biot's law. If you try to suppose take this point and current element લઈ લો, બરાબર? So arm position vector. So angle between ideal and R will either become 0 or will become 180. So in that case sin 0, sin 180, both are 0. So due to 3 and due to 4, how much magnetic field over here? 0. Clear? So બાકીનું કરવાનું છે, કરો. Again, consider them to be separate. B1 find karo, B2 find karo. And remember, both of them have how much turn? Half turn. બરાબર ને? Semicircle છે, half a turn. I hope you have done it now. We now the answer. Okay, did you find T1? Did you find T1, everybody? How much will it be? Mu 0 I by 2R1. Clear or not clear? Who understood that? Sorry, 4. That's right. બોલો n નો હાફ અને નીચેનો 2 ફોર્મ્યુલા તો 4 correct fine. Okay, now we do same thing, right? mu0 I by 4R2. So final answer what? mu0 I by 4R1. So final answer is going to be B is equal to mu0 I by 4R1 minus mu0 I by 4R2. Clear? Minus क्या पायु? Directions. Magnetic field is a vector. So आम से तो direction field direction क्या क्या? Dot or cross? Dot or cross? Dot is outwards, cross is inwards. So dot out, so this is dot. Okay, now what about D2? એમાં કરંટ આમ જાય છે, so it will be cross. So now when you have to find the total field, what should you do? You have to actually do subtraction because these are in opposite direction. Now magnitude. Clear? Understood? કોણે આ કન્સેપ્ટમાં ભૂલ કરી હતી? રેઝ યોર હેન્ડ. પ્લસ કોને આવતું હતું વચ્ચે? એટલે જ ગમે ત્યારે કોઈ પણ ક્વોન્ટિટી ફાઇન્ડ કરવાની હોય, think first of all whether it is a scalar or a vector. બરાબર? Vectors cannot be added directly. You remember that? Okay. Here is the next question. And don't forget the advice that I gave you right now. Otherwise you'll make mistake with that one also. Next time onwards we will continue with this chapter. એટલે તમારે વાંચીને આવો હોય તો આટલું થિયરી વાંચીને આવો. It was actually a little bit of surprise for me as well, કારણ કે પછી zero direct તરત પૂરું. Okay, otherwise I would have told you very well. Now, so remember that we have first of all the photo diagram and all that to complete, and tomorrow hopefully I'll give you an assignment of this, right? So that I don't have to write the question. કારણ કે હું ક્વેશ્ચન લખું તો તમે લખશો અને તમે બહુ ધીમે ધીમે ક્વેશ્ચન લખો, right? I know you sometimes try to buy time. બરાબર ને, એવું કહેવાય ને? So we don't want to do that. એટલે બધાનો ટાઈમ બચશે અને મારે આખું ઉપાડીને વેઇટ લિફ્ટિંગ નહીં, right? So be prepared with all the formula for chapter number 4, right? અને ઓલું ફોટો ડાયોડ ને બધું જે નોટ છે ડાયોડ નું વાંચી લેજો, ટ્રાન્ઝિસ્ટર ભલે બાકી રાખો વાંચો. ઓકે, 4-5 પેજ હશે વાંચો. And everything is very nicely described, so it's generally not have it's on this. Goodbye.